Imagine a world where humans are no longer the Homo sapiens we know, a world where diseases vanish, intelligence is enhanced without limits, and death is merely an option. Sounds like science fiction? Perhaps it's not as far-fetched as you think. Since the dawn of history, humanity has continuously transformed, from ape-like ancestors to cunning hunter-gatherers, then becoming the architects of modern civilization. But has that evolutionary journey ended? Or are we standing at the threshold of an even greater transformation, a biological and technological revolution that will shape an entirely new species? The question isn't whether we will evolve, but what will we evolve into? And what does that mean for our own future? Welcome to the Hidden Past channel and our series, Humanity's 70,000-Year Secret. In this video, we will explore the topic, Will Humans Evolve into a New Species? Don't forget to subscribe to the channel so you don't miss other videos exploring the mysteries of humanity. If you find the video interesting and useful, please like and share to support us.
Life on Earth has undergone billions of years of evolution, from the first single-celled organisms to the complex biodiversity we see today. The dominant mechanism behind this process is natural selection, where individuals with traits best suited to the environment survive and pass on their genes to the next generation. This is a slow, relentless process that has shaped all living species, including our own. Homo sapiens, or wise humans, are the product of millions of years of evolution from common ancestors with other primates. Our journey began in Africa, where traits like bipedalism, a larger brain, and the ability to use tools gradually formed. Each step of evolution was an adaptation to the challenges and opportunities presented by the natural environment. Approximately 70,000 years ago, a groundbreaking event occurred that Yuval Noah Harari calls the cognitive revolution. This wasn't a major biological change, but a leap in Homo sapiens' capacity for thinking, language, and communication. The ability to tell stories, create fictions, and cooperate flexibly with large numbers of strangers gave us a superior advantage over other human species. After the cognitive revolution, about 12,000 years ago, the agricultural revolution marked another turning point. Humans shifted from a nomadic hunter-gatherer lifestyle to settled farming. This led to a significant population increase, the formation of villages, cities, and ultimately empires. While bringing more stability and abundant food supplies, the agricultural revolution also came with new challenges regarding disease, hard labor, and social stratification. Next was the scientific revolution, beginning about 500 years ago, which ushered in an era of systematic discovery, experimentation, and knowledge accumulation.
Humans no longer simply accepted the world as it was, but began to investigate, analyze, and try to change it. This led to great inventions, technological development, and unprecedented changes in all aspects of life. It was the scientific revolution that laid the groundwork for what we are witnessing today, the ability to profoundly intervene in life itself. For millions of years, natural selection was the main driving force of evolution. However, over the past few millennia, especially in recent centuries, its role for humanity has significantly diminished. Modern medicine, technology, and society have created an environment where many individuals who would have been eliminated by natural selection can now survive and reproduce. Advances in medicine, such as vaccines, antibiotics, surgery, and treatments for chronic diseases, have helped humans overcome many survival barriers. Individuals with genes predisposing them to hereditary diseases or vulnerability to the environment now have a greater chance to live longer and pass on those genes. This reduces the pressure of natural selection to eliminate unfavorable traits. Modern society also provides a safety net and support system that previous generations lacked. Access to food, shelter, and education helps alleviate the harshness of the natural environment. As a result, factors that once determined an individual's survival are now less biological and instead depend heavily on economic, social, and cultural factors. However, that does not mean the evolutionary process has stopped completely. It's just that its driving force is changing. Instead of merely passively adapting to the natural environment, humans are increasingly actively shaping the environment and even themselves. Selection pressures may shift to new factors, such as the ability to adapt to technology, artificial intelligence, or the ability to survive in complex urban environments. Another challenge is the rise of diseases related to modern lifestyles, such as obesity, diabetes, cardiovascular disease, and mental health issues. Although medicine can treat them, these diseases still create certain pressures, though not in the traditional way of natural selection. The question arises whether our genes are adapting to a world full of conveniences, but also harboring many health risks. Climate change and environmental degradation are also new factors that could shape human evolution. If habitats become harsher, traits that help humans withstand extreme temperatures, resource scarcity, or exposure to harmful substances could become advantageous. However, the speed of environmental change is occurring too rapidly, potentially outstripping the adaptive capacity of natural biological evolution. Now, we are entering an era where evolution is no longer limited solely by natural selection. Instead, it is driven by human hands through groundbreaking technologies. We are becoming the architects of ourselves, with the ability to intervene in our genetic code, integrate with machines, and enhance our cognitive abilities. One of the most powerful technologies shaping the future of evolution is genetic engineering. In particular, the CRISPR-Cas9 gene editing tool has opened an unprecedented door to altering the genetic code of any organism, including humans. CRISPR allows scientists to precisely cut, replace, or add specific DNA segments with high accuracy. Initially, the main goal of genetic engineering was to eliminate serious genetic diseases like cystic fibrosis, Huntington's disease, or certain cancers. The ability to edit genes in human embryos or germ cells could prevent diseases from being passed from one generation to the next. This promises a future free from many of the severe illnesses that have plagued humanity throughout history. However, the line between treating disease and enhancing capabilities is very blurred. If we can eliminate disease-causing genes, should we also add genes that enhance intelligence, physical strength, longevity, or immunity to all types of viruses? The concept of designer babies becomes a realistic possibility, where parents can choose desired traits for their children. If a segment of the population has access to these technologies to enhance their biological capabilities, what happens to those who do not? We could witness the emergence of two biologically distinct groups of humans, an upgraded human group with superior intelligence, extraordinary health, and extended lifespans, and the remaining normal human group. This gap could create unprecedented social and ethical conflicts. Interfering with the human genome also raises profound questions about human nature. What happens if we change too much, to the point where we no longer recognize the traditional human? Will these changes affect the genetic diversity of humanity? And will we unintentionally create unintended biological or social consequences? Beyond gene editing, the field of synthetic biology goes further, aiming to design and build new biological systems or transform existing biological systems. Instead of just modifying what's already there, synthetic biology allows us to create biological components, biological devices, and biological systems with entirely new functions. This will be explored further in the next video, but it was also an important part of reshaping human evolution. Besides internal changes, humans can also upgrade themselves by integrating with external technology. Bionic implants and cybernetics are blurring the lines between biological bodies and machines. Sophisticated prosthetic limbs controlled by thought, electronic eyes capable of seeing beyond natural limits, or smart cardiac implants are early examples. In the future, we may see bionic body parts designed to surpass natural ones in strength, speed, durability, and sensory capabilities. A bionic athlete could run faster, jump higher, or a bionic musician could create more complex music thanks to enhanced fingers. These capabilities will redefine the concept of human physical limits. Brain implants are also a promising area. Brain-computer interfaces, BCIs, could allow humans to control electronic devices with their thoughts, or even connect directly to computers and information networks. This opens up the possibility of enhancing intelligence, learning, and memory, transforming humans into beings with superhuman cognitive abilities. These bionic and cybernetic enhancements not only restore lost functions, but also significantly expand human capabilities. We can envision people with X-ray vision, the ability to hear ultrasonic frequencies, or who can communicate instantly with each other via artificial neural networks. This will completely change how we interact with the world and with each other. However, integrating machines into the body also raises questions of identity. When a person has too many artificial parts, are they still human as before? The line between human and machine will become blurred, leading to new definitions of life and consciousness. This also carries risks regarding privacy and control, as bionic systems could be hacked or manipulated. Artificial intelligence, AI, is not just an external tool, but also has the potential to become a part of humans themselves through brain-computer interfaces, BCIs. Companies like Neuralink are developing chips that can be implanted into the brain to create a direct link between the biological brain and the digital world. This could bring incredible improvements in cognitive abilities. Imagine instant access to all knowledge on the internet, the ability to learn a new language in a matter of seconds, or complex computations without external computers. The human brain would no longer be limited by traditional biological processing speeds. Brain-computer interfaces could also enable an entirely new form of communication without the need for speech or body language. Individuals could communicate directly through thought, sharing emotions and ideas instantly and comprehensively. This could lead to a form of collective consciousness or supercognition, where multiple individuals can merge their intellects. Furthermore, some scientists and philosophers envision the possibility of mind uploading, which means copying the entire contents of a human brain, memories, personality, consciousness, onto a digital platform. If successful, this could offer digital immortality, or the ability to move consciousness between biological and artificial bodies. This is an extremely complex and controversial concept, but it is part of the vision of evolution extending beyond biological limits. However, these technologies also raise serious ethical questions. Who will control this technology? Are there risks of manipulation or loss of autonomy? And if consciousness can be uploaded, will that digital version truly be us or just a copy? These questions demand careful consideration before we go too far.
Although not evolution in the sense of genetic changes across generations, advances in pharmacology and longevity research are also reshaping human existence. New drugs and therapies can treat or slow down the aging process, significantly extending average lifespans and improving the quality of life in later years. The goal is not just to live longer, but to live healthier throughout life. Scientists are researching cell regeneration methods, gene therapies to repair DNA damage related to aging, and compounds that can activate the body's self-repair mechanisms. If successful, humans could maintain health and capabilities at age 100 or beyond. This could have profound impacts on social structures. With extended lifespans, educational, work, family, and retirement models will have to change. Will there be overpopulation? Will older individuals hold power for too long? And will extending life diminish the meaning of life if death is no longer a natural limit? Furthermore, if only a segment of the population has access to expensive life-extending technologies, this could create an immortal class and exacerbate inequality. The race to overcome death could become a technological and financial race, accessible only to the wealthiest and most powerful.
As humans begin to redesign ourselves, we face profound ethical and philosophical questions. How will the concept of human nature change when we can arbitrarily modify genes, implant machines, or integrate with AI? The boundary between natural and artificial will become blurrier than ever. One of the biggest concerns is inequality. If technologies that enhance human capabilities, gene editing, bionics, AI interfaces, become expensive and accessible only to the wealthy, we could create a new chasm between upgraded humans and unmodified humans. This could lead to unprecedented social stratification, with upgraded humans having superior advantages in intelligence, health, and longevity. Yuval Noah Harari posed the question of Homo Deus, God-like humans. Will these new beings still feel common ground with traditional Homo Sapiens? Will they view us the way we view other animals, or even as a less developed species? This could shatter the concept of a common humanity and lead to new racial, social conflicts and even the extinction of the old sapiens species. Self-design also carries unforeseen risks. Do we have enough understanding to intervene in a complex system like the human body and brain without causing unintended negative consequences? Genetic changes could have widespread impacts, affecting other bodily functions or ecosystems in unpredictable ways. Furthermore, there's the question of the meaning of life. If we eliminate disease, aging, and even death, were those challenges what shaped the value and purpose of human life? Will an endlessly prolonged life or a super intellect truly bring happiness, or merely prolong existence without deeper meaning?
We also need to consider the loss of traits once considered uniquely human. If emotions can be regulated, memories erased or added, and willpower influenced, will humans still retain their freedom and individuality? The risk of becoming programmed or externally controlled beings is an ethical challenge that cannot be ignored. Finally, the question of power and responsibility is paramount. Who will make decisions about how and to what extent we should intervene in human evolution? Will there be a global ethical committee that can set limits and regulations? Or will this be an uncontrolled technological race, where the most powerful determine the future of humanity? Based on the technological capabilities discussed, the prospect of a new species is no longer something that exists only in mythology or science fiction. We are at the cusp of creating a post-Sapiens species, a kind of being with capabilities far exceeding what we can currently imagine. Yuval Noah Harari calls this Homo Deus, God-man.
The concept of Homo Deus does not merely imply immortality or supernatural powers, but the ability to self-design and control one's own destiny. These new beings may not be bound by traditional biological limits, capable of resisting disease, extending their lifespan indefinitely, and possessing superior intelligence and creativity. They could become beings with powers akin to ancient gods. One form of a new species could be cyborgs, a perfect blend of biology and machinery. Their bodies could be enhanced with intelligent artificial parts, from stronger bones and more powerful muscles to sharper senses directly connected to a global information network. They could live in harsh environments where Homo sapiens cannot. Another possibility is the emergence of entirely new genetically engineered beings, not just to eliminate diseases, but optimized for specific functions. Imagine people designed to live underwater, or capable of partial photosynthesis to survive without traditional food, or able to adapt to other planets.
The future biodiversity of humanity could far exceed the diversity of current races. Furthermore, with the development of AI and BCI, we could see the emergence of Homo Sapien 2.0 with intelligence augmented by AI. They could process information at extraordinary speeds, learn rapidly, and solve complex problems that the traditional biological brain cannot. This is not about turning humans into robots, but about upgrading the biological brain with technology. Perhaps a new species will no longer be entirely biological in the traditional sense. Consciousnesses could exist entirely in digital environments, uploaded to the cloud, or housed in fully replaceable artificial bodies. This would erase the boundary between the material and the immaterial, opening up new possibilities for existence and experience. However, no matter what form we evolve into, it is crucial to think about humanity's core values. Can we preserve values like compassion, love, creativity, and the ability for emotional connection? Or will they be lost in the pursuit of perfection and power? The future of evolution is not just about technical capabilities, but also our ethical choices. In the past, human evolution was a natural, unconscious process. However, today, we stand at a unique moment in history where we can actively shape our own evolutionary future. Our decisions in the coming decades and centuries will determine whether Homo sapiens is the endpoint of evolution or merely a stepping stone for something entirely new. Change is not guaranteed to occur uniformly across the globe. Different nations, cultures, and ethical systems may adopt these technologies in very different ways.
This could lead to greater divergence among groups of people, not just economically, but also biologically. International laws and regulations will play a crucial role in guiding this process. One possibility is the emergence of multiple evolutionary branches, each adapting to a different environment or purpose. For example, one group might focus on surviving on other planets, developing adaptations to low gravity and cosmic radiation. Another group might aim to optimize intelligence and information processing capabilities, becoming knowledge beings living in digital environments. Should we set limits on what we can do? If we have the ability to change anything, are there aspects of humanity that we should preserve? These are questions that scientists, philosophers, politicians, and the public need to discuss together and seek answers. Societal participation is necessary to ensure that the future is shaped by common values. The decision of whether humans will evolve into a new species or not lies in our hands. It's important not only to develop technology, but also to develop moral intelligence and wisdom to use these powerful tools responsibly. We are designing not just the future of humanity, but also the future of life on Earth and potentially in the cosmos. Human evolution has never stopped. It has only changed form. From random genetic mutations and harsh natural selection, we have progressed to the ability to self-direct this process. Whether terrifying or promising, the future invites us to redefine what it means to be human. As we look into the promising yet challenging future of evolution, another crucial question arises. If we can redesign ourselves, what about designing life from scratch? Where are the limits of life when we can create it in a lab? That is the door opening to the era of synthetic biology, where scientists not only modify but also construct entirely new forms of life, from genetically engineered bacteria to never-before-seen proteins. Is this the next step in humanity's journey to master life, or the beginning of unforeseen consequences? In the next video, we will explore the era of synthetic biology, creating life in the lab, to better understand the amazing breakthroughs and complex ethical questions it poses. Don't miss it.